Okay, so the rotation of elements on a stereonet is pretty important. It's very important if you want to try and determine the orientation of something prior to the formation. But you've got to be careful, you've got to think geologically about this. For instance, here we've got two limbs of a fold, but on that one limb we actually have a striation. And now you would remember the striations are formed in sedimentary environments and they are usually deposited pretty much horizontally. Okay, so that's the first clue that you have to remember, that if this striation doesn't end up pretty much to the perimeter, close to the primitive circle, something is wrong. The other thing that you've got to remember is that striation only occurs on one plane, so you actually only have to unfold one plane. But you also have to think about the hinge line of that fold. So what you have is a fold. If you were to think of my hand as the limbs of the fold, and this here would be the hinge line, to make this back, bring this all back to horizontal, the one thing that you need to do is you have to bring the hinge line back to horizontal, after which you can actually then bring the limb of the fold on which you have the striation back to horizontal. The other thing that you've got to remember is you can't manipulate the great circles, so you've got to draw in the pole for the great circle that you want to work with. So in this case we will bring this great circle to this orientation, and we count off 90 degrees to get to the pole. 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees. 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees. So that is the pole to this plane. In this case we don't need to work with this specific limb, so you don't have to worry about it. But what you do need to worry about is the intersection point here, which is of course the orientation of the fold axis or the hinge line. So the first thing that we want to do is we want to bring the hinge line back to horizontal. And remember, the hinge line is not a pole, so the hinge line would be like this. So you actually have to bring it to the primitive circle. So to do that, we rotate it to the east-west reference line, and we want to bring it in this direction. And you can see that I have to move it with 10, 20, 30 degrees to get to this position here. Okay? When I do this, I have to move all the other elements as well with 30 degrees. So we go 10, 20, 30. That would be the new position of this pole, and also this needs to move with 30 degrees. 10, 20, 30. Okay? So that would be the new orientation of the striation. Now you can remove this, you can remove that, because that has been brought to horizontals. We're not going to worry about that anymore. Okay? And of course that is the new position of this striation. The next thing that we want to do is we need to now bring this pole back to, the vertical, to make sure that the plane will be horizontal. So we count in 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60, let's call it 70 degrees, okay? 70 degrees to come to this point. Of course, this now also have to move 70 degrees. So it will be 10, 20, 30, 40, 50, 60, and pretty close to 70 degrees. Okay, so now this has been brought, the pole has been brought to the vertical, which makes the plane horizontal. The striation is moved along this small circle, this position here, and then of course when you rotate your stereonet back to north, you will see that that would be the direction with zero dip for this specific striation before deformation. Okay. One thing that you do need to remember is that if for some case, okay, let's say for instance that this pole was still on the same great circle and we still had to move it 60 degrees, let's not forget that, okay, let's call it 60 degrees, but it was located here. How would you do this? We need to move in this direction as per the previous steps. So remember, we're dealing with a sphere, so when it exits the sphere on this side, it actually have to enter the sphere on the other side, over here. Okay, you will see one line away, so it will enter here. So if this had to move 60 degrees, 10, 20, 30, 40, 50, 60, that would have been the new orientation of that specific feature. And of course, that would not have been a striation in this case because it is not sitting on a perimeter circle. It could be anything else. But remember the way that this works when you actually go around the sphere. You actually come in back on what appears to be the other side. But remember, you are looking at a two-dimensional representation of three-dimensional data on a sphere, okay? And the lower hemisphere projection of that. So please keep this in mind.